I will talk about drugs and chemical compounds in the context of Wikipedia and Wikidata. I will talk about the brief overview about what the problem is with all public drug and chemical compound data. Then I will just give you a quick overview about Wikidata and what the Wikidata data model is we can use in order to improve. Then I will give you a quick idea about what we already did in a different context in the GWiki. On the GWiki project, I have been working on basically right here in the data, and then I will talk about the actual chemistry data. So the problem with the chemistry data is twofold. There's most public chemical databases like PubChem have very many compounds who have like suboptimal definition of the chemical structure, and there exist several versions of a compound with several structures. And specifically in the Wikipedia context, we have thousands of articles in different language Wikipedias talking about chemical compounds. And as I mentioned here, we have 300 different languages, so we have a gigantic collection of chemical information in the Wikipedias, but they are of different quality. They often differ between all projects on the same compound. So that's point one. The data is also not machine readable because it resides in Infoboxes, which means it's nice, it's parameters to Infoboxes, which is good if you want to display that to readers. But as soon as you try to reuse the data which are in Wikipedia in vast amounts, I think what you want to have is also the option to read that by computers. And the data is hard to maintain to update automatically, because what you would need to do as soon as data structure is released, or if there is an error which needs to be resolved, you need to go into this Infobox structure. You need to find and edit the correct thing. The data cannot be reused for other purposes because it cannot be read. If we say that the scientists should use the data downstream because we have an awesome chemical compound in there, it cannot be reused because it's not machine readable. So we think the solution for many of those issues is Wikidata, and I will now give you a quick run through why it is. So first of all, a quick introduction what Wikidata actually is. I think most of you hear of it. On the left, we have the antibody nivolumab as the Wikipedia article, and on the right, we have nivolumab as the structured data equivalent on Wikipedia, on the Wikidata. And these are linked by interwiki links, which are one hand used to organize the different language versions of the Wikipedias, and it's also a way to link Wikipedia articles to the structured data equivalent in Wikidata. So this is what it looks like. We have here different sections, you have case number, FDA, uni, then classifications. I think it's hard to read for you. And then it's the Campbell ID. So there's a ton of structured data on there, which is machine readable. There are two types of Wikidata items. There's the properties which define the nature of the thing, and there's the data itself, which might be the weight of a certain chemical compound, which might be external identifiers like links to other databases like PubChem. And we have currently approximately 3,000 properties in Wikidata, and now we even have already 25 million different items in Wikidata. So it's really strongly growing because we have seen grows about like 300 million statements within the last half year. So that is a really enormous growth happening in the Wikidata. And I think what's important to mention is all Wikipedias can access the data via the same mechanism and can reuse the data. So what does a statement as a statement about something look like? So it has a label usually. In this case, it's London. then it has a property like the edge I was talking about before. In that case, population, then this has a value of 8.1 million. And this is certainly 8.1 million at population. Obviously, it's not really valuable if you don't know at what point in time that's valid. So in that case, we say preliminary estimate of June 2012, that's a qualifier. And these three things, property, claim, property, value, and qualifier together called a claim. So if you make a claim about something, which you make a claim about something. In order to really make this claim useful, you would like to certainly reference this claim. You want to know where this reference came from. Is this a scientific article? Has somebody counted all people in London? How was this determined? And for that, there should be, for each claim, there should also be a reference. And if you have a reference claim, the whole thing is called a statement. And this seems like very simple now, but in the context of scientific use of this data, it's really important to know how this was done, where it came from, and so on. So we also have labels. This is more or less to make it more accessible to humans. So you have the label, description, and aliases. In that case, you have the FDA name or the internationally agreed name of this compound, which is the Walmart, then we have the description and pharmaceutical drug. And then we have a few other identifiers, labels basically, which just are development labels or codes from pharmaceutical companies. So this is important so you can find these things in Wikidata too. Because anything you search for, you can find that by the label also, not only by the structured data, which is there. So, and here again the references. So we do what for the data we import at Scripps, we do a ton of references because this is really essential. Because a reference, if people don't know where a certain claim is coming from, the value is basically zero because anybody can go into Wikidata and claim anything if they want to, but only if you have a reference, which is a scientific journal article, a textbook, a website which is a reliable source, you really can make downstream use of the data very efficiently. And I think James has done a great job by importing several hundred chemical compounds with very nice references. So that's how it should be done, actually. That's good. There are several data types also to finish the story about Wikidata. There are strings, other item IDs, then there are external IDs, which basically accession numbers to other databases. Then there are monolingual text where you want to specify what language a certain piece of text is in. Then there are other properties. There are quantities like the atomic mass unit of the chemical compound, for example. And then there is a time, there is specific URLs and field coordinates, and there are also commons media data type and mathematical formulas we also have now. The unique feature of Wikidata is because it's completely free, it's CC0, which means that anybody can use the data downstream without needing to attribute. And it's granular, it's single value reference statements. This means you can reference each single value, which is a great feature, I think. And anybody can certainly contribute. You do not even have a Wikipedia account. It's not only a repository for natural science data, it's also a repository for any data of any area of knowledge. It's a fully integrated semantic web that has a Spark endpoint, so you can easily access the data, use it downstream, use it on your websites if you're interested in that. And essentially, it's a gigantic graph of knowledge, but you need to be careful with the graph of knowledge because it's actually a term of Google. So they might not be happy if we reuse their marketing terms in the future. So now, specifically to the chemical space, after a quick introduction to what Wikidata is. I think Wikipedia does a great job on representing chemical compounds. These Infoboxes are really great. They have a ton of info. There are like 16,000 chemical compound articles in the English Wikipedia and like 8,000 in the German Wikipedia. But what you see, as already mentioned, you have this Infobox, and you have like general information about the medical implications of a certain compound. Then you have structured data and structured identifiers and structured data about the compound. But all of that needs to go into this Infobox markup code. You need to copy and paste that into there, into this box, and there is no way. There's no way that you can avoid that at this point. What the goal of what we do is essentially, and I started a big discussion on that on the Wikipedia Chem project. We want to use the data in Wikidata, so we don't need to populate all this stuff on the right side here. So in order to do that, we need to be able to pull it, to have first of all the good high quality data in Wikidata, and then we need to be able to pull that. So to pull that into Wikipedia Infoboxes. So technically, in the last year, last 1.5 years, the whole infrastructure was put in place, so this can be done. And what we already did for the Wiki project earlier this year, we defined a data model, and we showed how to do that in a gene protein space. And here is the Wikipedia article, which is up here. And this is the data behind the article for generating the Infobox in the Wikidata space. So we have essentially 5 major Wikidata items which are residing in Wikidata, and Julia Turner from our group made a Lua script in the Wiki for the Wikipedias to pull together that and render that as a GWiki Infobox. So, and as you can see, if you go to like this gene relay, essentially what you see is no difference compared to 2 years ago. But the data, the way how it's generated is completely different. So the whole thing is now completely rendered out of data from Wikidata. And that's what I aim for to do also for the chemical compound space. To remove all structured data from the Wikipedias and to allow the rendering the data from Wikidata directly into Wikipedia. There has been a large discussion already on that in the Wikipedia Chem project. We'll point into that later. So the reason why we want to do it, why this should be unified in Wikidata, is because we have a ton of incorrect identifiers in the Infobox. It's improving over time, but there's still a lot of room for improvement. There's incorrect chemical properties like incorrect weight, etc. There's incorrect labels of aliases. But where it really starts to get problematic if there is incorrect isomeric forms of the compound, or if it's a mixture of different isomers. If you have external identifiers for 2 different isomers in the same Infobox, it gets chaotic and incorrect, and this needs to be resolved before we can go forward. So isomers, just quickly, there are constitutional isomers which look the same but have different connectivity, so that's not a big problem. Then there's stereoisomers, which basically this left and right hand problem, if you remember that from high school. And diastereomers, enantiomers, cis-trans isomers, and these things start to confuse people who want to contribute because they all look somehow similar. It's hard from the structure to really see what it is. But I think we need to be very careful how we represent those, because if we get it wrong, the value of the whole effort we do here to have open public chemical data is somehow spoiled because it's incorrect. So we need to really take a lot of effort to get it correct, and concentrating the data the correct data in Wikidata is it would allow us to remove a lot of error points. And this is the major driving force from my perspective in the Wikipedia context. So how do we resolve the isomerism issues? So I think we need to make sure that data in Wikipedia are consistent on the INCHI, or INCHI is International Chemical Identifier for UPAC. And this key allows, or this string allows you to tell what a certain Wikipedia is actually talking about. So what I'll just quickly, UPAC, International Chemical Identifier, describes the structure of a chemical compound or substance. It's freely usable. It's not like the CAS number, Chemical Research Service, which is not so free. Can be computed from other chemical structure formats. And you do not need an organization to assign this value, because for Chemical Research Service, they do a great job, but for each CAS number you need needs to be assigned by them. So what is this key? It's a hash 265 version of the INCHI. It makes chemically searchable in the web, and it's also very important in the semantic web. It makes chemicals comparable, and it's short and neat, because it's only like this small thing. And then the first part is composed of the skeletons, or the connectivity between the different atoms. And the second is the stereochemistry, and then there is a charge in the end. That's not true. So what we want to have as a minimum requirement on a chemical compound in Wikidata is that the INCHI key or the INCHI is correct. Because then, so best the scenario is certainly the smiles and penalty smiles and INCHI are all correct. But for that, if the INCHI key is correct, we can import everything else by programs by blocks. And what has been accomplished so far? So we're working on that. I have written a block which does a lot of that things. So it imports everything. If you have a unique INCHI key, it can generate you a whole Wikidata item. Here is the discussion on the Wiki project chemistry. Currently, I have cleaned up from 60,000 chemical, 7,000 chemical compounds. I have cleaned up 60,000, and yeah, we can move on from there. So there is 1,000 to handle. So I have a list in there. You can go in there and create those. And with the link to this, this needs your attention. If you want to work in chemistry, just go in there and spend your Sunday on coding that. So the data maintenance, the cool thing is it's all working via Wikidata APIs. And we can do that with Python scripts as long as we have some anchoring point, like a correct structure of chemical compound, so we can import any chemical stuff we want. Okay, let's skip that. So thanks to my team at Scripps, I in pursuit. Tim talked earlier about his micro interface and genetics part. And thanks for your attention.